Assalamualaikum and very good evening. My name is Nurul Hamimah. So today I'm gonna talk about differentiation. First, I will explain it in one simple video. First of all, what is differentiation? Well, differentiation is a method of finding the derivative of a function. Differentiation is a process we find the rate of change in function based on of the variable. The opposite of finding derivative is anti-derivation. If x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. The general equation is fx equals dy over dx, which y, fx, and any function. We also have differentiation rule, which is first, sum and difference rule. The second one is product rule. The third one, quotient rule. And last one, chain rule. Then, why we use differentiation? Because we want to solve the related rate problem. A related problem is a problem in which we know the rate of change of on it, the quantities, and we want to find the rate of change of the another quantity. For example, the two variables bs and y, then their relationship are expressed by a function y equal to fx. The rate of change of the variable s and y are defined in terms of their derivative dx dt and dy dt. If we know dx dt, then we can determine dy dt. That is the simple introduction of differentiation. We can simply say that differentiation is a process of finding a derivative of a function. If x and y are two variable functions, then rate of change of x with the respect of y is a derivative.
The example of related rates that we can relate with our daily life is inflating a balloon. As we inflating the balloon is expanding at a constant rate. So now we are going to discuss about the rate at which the volume of the balloon is increasing, as well as the rate at which the radius of the balloon is increasing. So both of these values are increasing due to the expansion of the balloon, and their rates of increase are related. So this is what we call related rates. Problem statement. First, calculate the radius of the balloon at which the volume of the balloon is 100 cm³ per second. Second, how can we find the rate of increase for the radius of the balloon when diameter is 50 cm?
The next one is we try to solve the problem, which is calculate the radius of the balloon at which the volume of the balloon is 100 cm³ per second. How can we find the rate of increase for the radius of the balloon when diameter is 50 cm? So first we have to remember that the balloon have a spherical shape, so the formula to calculate the volume is 4/3 pi r³. Now from here I can write as dv over dt equal to 100 cm³ per second. Now the question is to find the rate of increase for radius, means that dr over dt when the radius is 25 cm that we get from the diameter. So step 1, we try to separate dr over dt into two parts. Now the value that I'm going to substitute here is depend on the information that we have. So the information that we have is dv over dt, so I'm gonna substitute dv in numerator and denominator. Now the value for dv over dt already given from the question, so we just need to substitute into the formula. So now we just need to concentrate on this part, which is dr over dv, and we know that the formula to calculate the volume for a sphere is 4 over 3 pi r cubed. So means that we have to differentiate the volume with respect of radius. So from the question, we want to find dr over dv, but we have dv over dr, which is 4 pi r squared. So in order to find the volume of dr over dv, we just need to put 1 over 4 pi r squared. So back to the equation, dr over dt equal to dr over dv multiplied by 100. We just need to substitute the value for dr over dv, which is 1 over 4 pi r squared. So from the equation, when diameter is 50 centimeter and radius is 25 centimeter, then I'm gonna substitute r into the equation. And the final answer is 1 over 25 pi.
So here's the conclusions. The conclusion we can make here is we can use related rate for quantities that are changing over time. The rate at which these quantities change are given by the derivative. If two related quantities are changing over time, the rate at which the quantities change are related. In this balloon's equations, a balloon is being filled with air. Both the radius of the balloons and the volume of the balloons are increasing. So there are two quantities that are changing over time in these situations, which is volumes and radius. Volume is increased by 100 cm cubes per second and radius is 25 cm. So we can calculate change of radius over time by finding equations that are combined this volume and radius. Balloon is a sphere, so we need to use equation of V is equal 4 over 3 pi r cubed. Then we need to differentiate it with respect to the time. Related rate also can be used for the daily life problems other than just balloon problem that we did just now, as long as there are two quantities that are changing over time. So here's the step-by-step that you guys can do to answer the questions of related rate. The first thing that you guys need to do is try to find the equation that combines both of the quantities. Okay? And number two, when you know the equations, you need to differentiate it with respect to the time by using chain rule. And lastly, simply solve the question by adding every info that are given to you into the equations. So that's it. That's how easy the question of related rate it is. It's hard for the first time, but I know it will be easy if you keep doing. So that's it from me. That's it from my team. And thank you for listening, and hopefully you guys can understand our presentations, and see you next time. Thank you.